lessons over simplifying rational expressions. You definitely need to watch most of this one, especially 3 and 4, because we may leave it in a simplified manner that you wouldn't actually be expecting. Okay, so number 1's pretty straightforward. When we simplify this, we're just going to want to FOIL the numerator. So we would end up, when we FOIL, when you FOIL, we would end up with 2x squared. Outsides would give me 2x, insides would, negative 2x, insides would give me negative 3x, so it's negative 5x, and then plus 3. I don't think I need this leading parenthesis anymore, so I'm going to get rid of it. On this part, I'm going to distribute my negative as I write it down, minus x squared, and then when we distribute, we get plus 3x. Let's change this, by the way, change question. Let's change that to a plus right there. And I'm going to leave it factored. So we're changing to a plus, and we're going to leave it actually in factored form instead of FOILing. Now I can collect like terms. When I collect like terms, the 2x squared minus the x squared is just 1x squared. The negative 5x squared plus the 3x gives me minus 2x, and then we have the plus 3 at the end over the x plus 1 squared. So you might think you're done, but if you notice, the top is factorable again. So this factors to, what's it factor to? X plus 1, x minus 3, I believe is what it factors to, over the x plus 1 squared. Now, if you notice, you can reduce. So we must factor the top if it's factorable to see if it reduces. And it does. This goes away with one of these. So my final answer is x minus 3 over x plus 1. If you didn't reduce this and you stopped over here at this one, you would get points off for not being fully reduced. So final answer again, reduced answer is the x minus 3 over x plus 1. Okay, I'm going to need to move this one. Let's group it together. Shove it a little further over. And let's move on to number 2. There's several ways to do number 2. Several ways. We might actually do 2 ways here. The first way, you might just think of, instead of dividing, let's multiply by the reciprocal. So this does mean 1 over x plus 3 minus 1/3 divided by x, correct? That's what it says. But instead of dividing, we could multiply by the reciprocal. So it's times 1 over x, which is fine to do it that way. Once you've done that, you could distribute. When I distribute this fraction to each part, we get 1 times 1 is 1 over x plus 3 minus 1 over 3x. So we have that, but then again, of course, we're going to need, yet again, common denominators. So the common denominator here would be 1 of everything, so we'd need a 3, an x, and an x plus 3. That gets you 1 of each factor in the denominators. So let's change colors here. This first fraction that we have right here, the only part of this new denominator, the LCD, that I'm missing is the 3. So I would need to multiply by 3 on the bottom and 3 on the top. So the only thing, 3 times 1 is a 3 there. Now we're going to put down our minus that's here. We'll put it down here. The second fraction, it has a 3 in the x, so it's missing the x plus 3 since I put it on the bottom. have to also multiply it into the top. Now here's where people are going to make a mistake. Make sure you understand that you're going to need to distribute the negative into that binomial. Switch back to blue. So now the numerators, 3 minus 1 times x is x, it's negative 1 times x is negative x, or minus x. Negative 1 times positive 3 is minus 3 over your 3x, x plus 3. From here, I think you can figure out that the 3 minus 3 cancels, so we end up with negative x over 3x, x plus 3. And the x's cancel. The x's cancel. And so we end up with a final answer of negative 1 over 3 x plus 3. You're welcome to distribute the 3, but you don't have to. Okay, I'm going to have to erase that, so pause the video if you're not quite finished. And let's move on. Number 3. On number 3, this is a part you wouldn't know without watching the video. On number 3, the way we want you to simplify this is just by rationalizing your numerator, which I know is backwards from normal, but this is something you'll have to get used to in calculus and some of your upper level math classes. So to simplify this, we're just going to practice rationalizing the numerator. The way you would rationalize this one is by multiplying by the conjugate. Remember that word, conjugate? So the conjugate of the square root of x plus 3 minus 4, the conjugate of that would be the square root of x plus 3 minus 4. If I'm going to do that to the numerator, I have to do that to the denominator. So remember conjugates. We like conjugates. Conjugates are beautiful because when you multiply by conjugates, the outsides and the insides cancel. So here we go, foiling out. The square root of x plus 3 times the square root of x plus 3, a square root squared, ends up being just the argument. The argument's the part underneath, which is the x plus 3. Now, here's the beauty of conjugates. That's a negative 4 square roots of x plus 3. Well, now you'll notice that I didn't write the conjugate. The conjugate is actually a plus. Sorry about that. I can't rewind the video. So the conjugate is addition. So here we go. Square root of x plus 3 times 4x is positive 4 square roots of x plus 3. The insides here is going to give us negative 4 square roots of x plus 3. So they're going to cancel. And then the last will give me negative 16. Look how nice that is. The bottom, you don't need to distribute at the moment. So we're going to end up with this one being x minus 13 times the square root of x plus 3 plus 4. Let's simplify the numerator. We're going to end up with x minus 13 over, and let's go ahead and FOIL that out and see what happens with that. We may want to leave it, but let's see. X square roots of x plus 3. The outsides would give me plus 4 x. The insides would give me minus 13 square roots of x plus 3. And the last would give me negative 13 times 4, which would be negative 52. Nothing combines on that. So I actually would take an answer like this, or it might be better to just leave it x minus 13 over your x minus 13 Oh, wait. What am I thinking? We should cancel these, couldn't we? Let's look at this. X minus 13 square root of x plus 3 plus 4. Let's look at that. These cancel, don't they? I didn't even notice that because I distributed. Let's do that. So we end up with 1 over the square root of x plus 3 plus 4. That's nice. That's the one we want. Okay? That's the one we want. So we would not want to do this. That's too complicated. So let's stick with that. Last one. Last one would be on this one. This one's, again, a little bit odd, something you wouldn't think of. What we want to do on this one is make sure you understand right here that negative exponent can be moved to the denominator. So this would be, let's leave the negative 1 on top. Let's move to the bottom the negative x, and when I move it to the bottom, it would be negative x squared. Excuse me, I'm not moving the negative. When I move it to the bottom, it would just be x squared. The negative's going to stay on top, times 1 minus 1 over x squared. Now, what we want to do with this is we want to actually put this square root back, this squared term back into the square root. So think this through. If I want to know what equals x squared, what would be under the radical? Obviously, hopefully you understand it should be x to the 4th if it were in there. So what we're wanting to do is take our square root of x to the 4th and multiply it back in to this. Okay, and of course we still have our negative 1 sitting on top. So it's negative 1 over, now I can multiply these. It's going to be the square root. We're going to have to distribute in. Square root of 4 times 1, x to the 4th times 1 is just x to the 4th, minus, and this next one would be x to the 4th, I'm going to do it over here, x to the 4th over x squared, which is just x squared. I know that's an odd way to leave, it, but that's something we're wanting you to practice. Now, if you wanted to rationalize that, which you may not, but because this is a fine answer, make sure you know that's a negative 1 there on top. If you wanted to rationalize this, of course, you would multiply by the square root on top and bottom, and you would end up with over, and that would be, and don't forget you have a negative. That would be your rationalized answer. You need to be able to do and recognize both.